This arrow illustrates the distance around, also known as circumference. Okay? And circumference is measured as pi multiplied by the diameter, or you can utilize double pi times the radius. Why? Because the radius is half of the diameter. So both of these things are saying the same thing. I will always say this. That is how I learned it. To me, why add an extra step? That's how I do it. But if you're somebody who has learned this in the past, use that thought process. Okay? Doesn't matter to me which way you learn it. Now, to zoom in and look at a circle. So this would be like the center. And the distance across is the diameter. And this distance here is the radius, which is center to edge. Okay, that's radius. So again, depending upon which path you choose to recall, either method will work. The meteor crater that they've identified. Let's look at example 1. Scientists have identified the faint outline of part of an ancient meteor crater on the coast of Mexico. The rest of the approximately circular crater lies underwater. The crater's diameter is about 100 kilometers. So what they've drawn is the shoreline, right? And they approximated the edge of the crater. Okay? That's what this horrendous sketch is attempting to represent. But if you can envision it going off into the water, you have a nice circle. They said to you the diameter of the crater is about 170 kilometers. What is the distance around the crater? If you're looking for the distance around something, around a circle, you are looking for circumference. Pi times diameter is circumference, also known as distance around. Okay? Pi times 170 will give us circumference. Most of your calculators should have a pi button. And if it doesn't, mine doesn't either, 3.14 is your value for pi. So 3.14 times 170 will give you that. Approximate to the nearest kilometer. Okay, to the nearest kilometer, Allie, what will I do with this information here? If this is what they've given, how do I round that to the nearest kilometer? Good job. A lot of you are still rounding incorrectly, and when I grade your work, I've been writing the words rounding error on your work. Okay? If you don't know why it's a rounding error, you may want to ask either myself or a friend to figure out what step you might be missing. Okay? Because rounding errors are going to get you in trouble. Okay. This is what you do if you know what pi is, which we do, and you know what the diameter is, which we did, and you want to obtain the circumference. What example 2 does for us, we've moved up to the top of page 529. What example 2 does for us is say the circumference of a circle is 70 inches. Find the radius. So circumference is 70 inches. Find radius. Now, depending upon which of those two formulas I showed you, you might take one path or the other. They're showing it this way. If I did this information, I could do that as well. Okay? So let's do the one they're showing us. 70 is equal to 2 times pi, 3.14, multiplied by r. Does everybody see why I plugged what I plugged in? After multiplying 3.14 by 2, you have that. To solve for r, you plug in 70 divided by 6 and 28 hundredths, and you should have come up with a radius of 11.1. And since they said nearest inch, Kat, how will I round this to the nearest inch? Okay, so what do you round it to? Good, because this guy is less than 5. Wonderful. If I used this version of the formula, I would do the exact same thing, only when I found the diameter, I'd have to cut it in half. It would look like this. Diameter is equal to the quotient of 70 and 3.14, which is 22.29. Cut in half to get radius, I get something like that. Rounded to the nearest inch, I still get 11, don't I? Okay? So either way will work. I don't care which method you use. I have this one memorized, so I always go back to this one. And if I receive diameter and need radius, I just chop diameter in half. Okay? How you guys feeling about this? Good. Is this really new to anyone yet? Didn't think so. You guys all looked like you were okay. Okay, so that was circumference. Let's do area. In a polygon, it's easier to solve for area. Quadrilaterals, we did base times height, and triangles, we did base times height divided by 2, and trapezoids, we did this, half the sum of the bases times the height. In a circle, there is a different formula. It involves pi as well. Area of a circle is defined as pi times the value of the radius squared. Okay, that is going to be what you're going to see. They're not going to refer to diameter anywhere. Its area is defined as pi times the radius squared. Depending upon what data you're given, you can find area. In example 3, they've sketched a circle that has a diameter of 26 feet. Is that what I need in this formula? What must I do?
By 26 by 2.
And you get
13.
13. Area is equal to pi times the radius squared. Area is equal to pi times the radius squared. So the radius squared is 169 multiplied by 3.14, and you should have come up with 530.66, right? And what it says is wants the nearest square foot. It wants the nearest square foot. 531, good. Okay? How you guys feeling about this? All right. Please look at example 4. I'm sorry, checkpoint 4 on the bottom of 529 with me. Checkpoint 4 on the bottom of 529 says this. One circle has a diameter. Do you need something? Okay. One circle has a diameter of 12. And I'm drawing them identical because I don't want to give the answer away, even though some of you already see it. The other circle has a radius of 7. Which one has a greater area and why? Go ahead, Haley.
Radius of 7.
Yep.
If you divide the denominator by 2, you get a radius of 6.
Yes. If you divide this guy's diameter in half, you get a radius of 6. So pi times 36, r squared, is going to be smaller than pi times 49, which would be r squared over here. Okay? So this will have a larger area for that reason. Okay? Let's flip the page. We're almost done. If you are given a portion of that equation and you need to find the radius of a circle to the nearest millimeter, you can utilize the equation pi r squared and plug in what you know to solve for the unknown. They gave us the area. Do we know what pi is?
3.04.
And they want us to find the radius. We don't know what the radius is. To solve for the radius, we divide the coefficient of 3.14 into each piece, resulting in r squared being equivalent to, they've got 22.9. 72 divided by 3.14 gave me 22.9. And rather than even mess with it, simply write square root of answer if your calculator has that ability. And you should get something that looks like that, which in the book they rounded to 4.8. To the nearest millimeter, r is the square root, so 4.8. To the nearest millimeter, Sadie, what will it be?
5.
Okay, solving for the missing piece of information. Haley Justice, I think you guys will remember example 5 from last year's Math Olympics practice test.
Yeah, that was great.
Super, super similar. Okay. Oftentimes in life, things are not just circles or just squares, and you are forced to find the area of items using a variety of steps. This shape, to the best of my ability, is a half circle combined with a rectangle. I am not going to draw all the little swoops and hooves.
This is actually much easier than last year, because last year we had to find another part of the window.
Yeah, and there were like side windows,
Yeah.
and then like a little birdhouse on the side, and we had to find it.
And there was a cat walking through, and you had to determine, yeah.
We had to determine how fast he was going.
Find the area of the rectangle, I'm sorry, of the window. Is there anybody who can't find the area of this portion of the window? 4 times 8 1/4, would you agree?
Yes.
4 times 8.25. 33. Is it feet?
Yeah.
Okay, 33 feet squared. Assuming I were artistic, the above arch would look like a half circle. What's the diameter of that half circle? What's the radius of that half circle? They've given me nothing. How can I figure that out, Brandy? How can I figure out what the radius of this circle is, what the diameter is of this circle? Do they give us anything that might be useful for the diameter of this half circle? 4 feet. Good. Just because the measurement down here is down here doesn't mean it doesn't apply to this. So what you're looking at, just to kind of sketch it elsewhere, is half of a circle. Okay, this is the other half that doesn't exist, that has a diameter of 4 feet, right? And how do you find the area of a whole circle? Whole circle, whole circle.
Area of the whole circle?
Give me the area of the whole circle with a diameter of 4.
1/2 by square.
Well, the half would be half the circle, yes, you're exactly right. So he just basically said, well, the area of the whole circle with this would be pi r squared. Half of it is just going to be half of that number. So to start with, I'm going to find the whole thing and then just chop it in half. So it's going to look like this. 3.14, what is the radius of a 4-foot diameter? 2, good. 2 squared is? 4. Just so happens to work that way with the number 4. 3.14 times 4 is going to be 12.56. But we only have half of a circle.
Chop it by 2.
Divide it by 2 and you'll end up with 6.28 is the area of the half circle. They don't ask for each piece, they ask for a total. 39.28. If they wanted you to approximate to the nearest foot, it's going to be?
39 feet. Split.
Very good.
Yeah,
There's a variety of reasons why you might need that. You might need that to paint a room that has a looped or a curved ceiling or curved roof or a curved wall. When you buy paint, they ask you what the area is you intend to paint. You can guess and spend too much money, buy too much. You can guess and be wrong and then have to go back to Menards. Or you can utilize the skills you already have to find the walls area. Okay? That's what this is all about. All right, my friends. I'm going to let you guys get started.
I fucked that.